So this is like a model. You are building a model. For example, if you conduct an experiment to determine, let's say, the effect of temperature on the strength of a material, the strength of a material, and if this is a material, for the experiment you have for different materials. So you want to know the effect of temperature on this material. So the strength now, the strength is a kind of the output, while the temperature is the input. So you see that the temperature is an independent variable, while the strength is dependent. The strength depends on the strength and temperature. So in this regression, we are trying to build a model where we just insert the temperature of the material to give us the strength. That is the nitty-gritty of this topic. So we want to build a model. So for every material, once you put the temperature there, to give you the strength. So the let's say the strength is y is equal to y, and the temperature is equal to s. So our y is a function of s. So in this case now, the output strength depends on only one variable. So in this case, we call it simple regression. That is, since we are not working with only one dependent variable. But in real life, it doesn't occur like this. It depends on more than one variable. So it's called simple line regression model. So the format for the model is y is equal to a plus bx, where a and b are estimators. A and B,
they are the
estimators. Yes, they are the estimators. So the A is equal to y bar minus bs bar, and the B is equal to the summation of the product of I and y from I equal to 1 to n minus n is the total number of samples times the mean of s and the mean of y, all over the summation of the s squared from I equal to 1 to n minus n x squared. So let me explain the formulas. So the first one is that A is equal to y bar. This is the mean. To find mean of anything, you add all the values and divide by their numbers. So our y bar is equal to summation of the different y's, and the value of this value of y now can range from I equal to 1 to n all over n, gives you the mean value. The same thing goes for s bar, which you sum the entire s that you have, which can range from 1 to n all over n, the total number of y. So to get a completely, we need b. So the b is equal to that you should multiply s and y, multiply the value of s and y individually, then you sum it up. This one now, the total number of samples times the mean of s times mean of y all over each value of s, square it, then sum everything. This one now say the total number of samples times the mean, square the mean of s. So it's not hard. Let's do an example. A raw material used in the production of a certain synthetic fiber is stored in a location without a humidity control. Measurement of the relative humidity in the storage location and the moisture content of a sample of the raw material were taken over 15 days with the following data. So the S here is the relative humidity, Y is the moisture content. So we know the meaning of humidity now is the amount of moisture on the atmosphere, and a raw material was stored. You understand that the amount of air in the atmosphere will impact on the moisture content of that material. So the moisture content of the material now is dependent on the relative humidity of that environment. So once you build a model such a way that immediately you put the humidity of a particular day, it will tell us the moisture content of that material without carrying out an experiment to know the moisture content. So that's what the model does. You use data and form the model. So you just, once you insert the humidity of that particular day in your model, to give you the moisture content of that material. So the formula is y equal to a plus bx, where a and b are the estimators. So let's find our a. Our a is equal to y bar minus bx bar. So our y bar is that you sum all your y's. You do 12 plus 15 plus 7 plus 17 plus 10 till the end. I didn't complete the material, I didn't complete it.
No contain, then we add it from the material.
Put out for that.
Precise only. You should add the value of y, right? You should add it.
Y bar is
Y bar.
the mean of y. So we do 12 plus 15 plus 17 up until the end, which is 12. Over, you now count it. How many are there?
15.
15. Anything you get becomes your y mean. Anything you get becomes your y mean. Similarly, for S mean, you sum 46 plus 53 plus 29 up until the end of 4 all over 15. You get our S mean.
15.
12, 15, 7, 6, 10,
So the
11,
y bar is equal to 12.4 and the S bar is equal to
37.
46.9. So our A estimator is equal to 12.4 minus B bracket 46.13. So for the estimator B, it is equal to so the first thing to find here is to multiply the corresponding S and Y. You multiply S and Y, keep the answer plus S and Y plus S and Y plus S and Y to exhaust for the 15 days.
Form a table.
Yeah, for the table. So our summation of S I
Are you going to form a table for that?
no
Okay.
Check on the unequal is out.
46 times 12 plus 53
Thanks.
times 15.
I think it's better to form a table.
Anyhow, Sean.
Just create an extra
Extra table.
Extra table and make S Y.
Because it can the sun no don't know.
S1.
big mistake.
The last one will be 44 times. So we can form an extra table here of S and Y.
46 times 12. Move
5, 5,
53 times
7, 9, 5.
You're supposed to get
29
8,
times 7.
8, 9, 9, 7. So this for this one. So this one is saying to multiply the number of samples times mean of S times mean of Y.
Okay.
So our
That
N,
will be 15.
yes, so our N is 15. That's our S bar. Our S bar is likely this 46.1.
46.13.
And our Y bar is 12.4. So let's point this one. So yes. Maybe we can punch this thing. 15 times 14.6.13 times 12.4.
The last one, Abi.
Yeah.
Okay.
8580.18.
35,
580.1.
3, 5,
85.
8,
8580.
8, 5, 8.
8580.18.
Mhm. So the next one is you should square each value of s
Okay.
and sum all of them together.
This question. Let's go finish am first. Huh?
This one are less, this one are small. The value
No, what I'm talking
Yes.
is that means maybe the number of n will not be up to 15. Because
In the exam, abi?
yeah, if it is 15, that is wickedness. Part of the
Lecture.
yes.
So for summation of
X.
xi squared, we have 46 squared plus 53 squared. This in the exam, if you do it again to construct the answer. Plus 29 squared. What was the last one? Last is 44. Yeah, the thing is almost
So
inevitable.
we should still do the value of y square. abi?
No, s squared.
Okay.
No
You
y squared.
No, y
Okay.
squared. So you square every x.
Mean of y.
Okay.
Mean of x. Then mean of x 1 x squared.
Easy o.
Sorry.
So if we sum the squares of the individual s, we are going to get 3, 3, 1. Then this one we're asked to multiply the total number of samples times the square of the mean. S mean. Yes. S mean. Yes. So at the end of the day, our B estimator will be equal to, this one is 8997 minus, this one is 858 0.1 all over. This one is 33212. And our n is 15 times the square of our s mean, which is 46.13 square. So let's punch this thing. Sir?
That means that 8582 is correct. That is
8580. This one.
It's correct.
It's correct. I want to explain something here, but let's finish what we are doing.
Okay.
This one give you.
Somebody should shut down.
So, but one is correct. 1292. So it will be 0.32. 3, 4, 0.346. So from the material,
32. No, I know when.
so from the material, you see that they did 46.13 times 186.
Okay.
Let me explain what they did. But this is how to do it. But let me explain what they did. Can you hear? Can you hear?
Yes.
You know what is y bar?
Oh,
No, y bar is sum of what? Summation of what? Y.
How do y?
Over n. Abi? You place it here, we'll have n times s bar. Abi?
Yes.
Times sum of y. Abi? Over n. You cancel out. This thing is n s bar y bar.
Okay.
I replace my y bar with sum of y over n. So that n will cancel n. Now I am left with s bar summation of what? Y. So what's our s bar?
14 point.
Is it 14?
S bar. 46.13.
46.13. What's our summation of y? Summation of y.
Submission of y.
186.
186.
186. So either ways, you still get the same answer.
This one is correct.
It's correct. Yes, not because if you're in the material, you will not see. They will not do 15 times
Extra.
46. They did it like that. So either ways.
Yeah, no, 15 good. Don't count.
Remember that our A is equal to. Is our A is equal to what again? A is equal to. Please remind
Y
me.
bar,
No, the equation for our A.
Why
y
bar?
The equation.
minus dx.
The equation for like we replace the y bar now.
Okay. 12.4
12.4
minus b
46.1.
46.1.
46.1.
Okay, 1,
That's
Three.
1.
3.
So our A will now be, we now replace our B with 0.32. So our A is now equal to what? Let's point it.
Minus 2.36.
Minus 2.36. So remember that our model y is equal to a plus b x. So y is now equal to minus 2.36 plus 0.32 x. So s is the independent variable which is the relative humidity. So for any value of x, it will give you the idea of what the moisture of the material will be. So that's what regression is talking about. They can ask you what is the moisture content at relative humidity equal to this. Once you plug it here, so you can go, if you go to your table now, you put any value of s from that table to give you the corresponding value of y. You don't have to check if your answer is correct or not. Let's pick a value from that table. Pick s equal to. Let's pick s equal to
36.
30. Okay.
36. So our y will be equal to minus 2.36 plus 0.32. So what is that going to have? Let's point it. 9.16 is approximately. This gives you an idea. So if you table now, the answer is 10. So the next aspect of regression is interpreting the result. Like if you get, once you get the results, you want to know why the result is that way, why it is in the format that it is. So in this case, we're going to look at the coefficient of the coefficient of determination and sample
What page is that?
P7
Next one.
sample correlation. So the coefficient of determination is denoted as r squared. The coefficient of determination is at r squared, and the coefficient, the sample correlation coefficient, sample correlation coefficient denoted as r. 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 And the value of R squared is between 0 and 1. The value of R squared is between 0 and 1. Value of R squared between 0 and 1. And R is equal to the square root of R squared. So if you recall the example we solved initially, where we had the relative humidity S, relative humidity, and Y to be the moisture content. So this R value is trying to tell us, want to explain why is it that at different values of relative humidity, we're going to have different values of moisture content. So this R value is going to tell us the cause why it is so. So you see that if the value of R is close to 1, it indicates that most of the variation, that is the difference in the value of the moisture content, is explained by the different input values. That if you solve for R squared and you get any answer close to 1, it means that the cost of the different values of moisture content is because of the different values of the relative humidity. But if it's near 0, it means that the different values of relative humidity has little effect on the moisture content. You have to interpret the results that you get. That if the value is closer to 1, the difference in moisture content is due to the difference in the relative humidity. But if it's closer to 0, it means that the relative humidity has little or no effect on the moisture content. That's for R squared. Then for R, please can we take that one again? Okay. In the first example, we looked at that a material was stored in a raw material was stored and for 15 days, so each day they'll take the relative humidity of that material and also check the moisture content of the material. They did that for 15 days, so they can build a model to predict what the moisture content will be anytime, any day. You understand? So I think that this topic, that the coefficients of determination and sample correlation coefficients, explains the results. It interprets the results per se. So when I say that the value that R squared is denoted, the coefficient of determination is denoted as R squared. And this R squared value ranges from 0 to 1. From 0 to 1. That tells us that if the value of R squared is closer to 1, it means that the difference in the moisture content is caused by the different values of the relative humidity. If it is closer to 1. But if it is closer to 0, it means that the relative humidity has no effect on the moisture content. That's the explanation. Then R can either be positive, or negative. R can either be positive or negative. That a value near positive, that's a positive value, indicates that remember that in this R squared, we're able to establish that if it is closer to 1, it means that the relative humidity has effect on the moisture content value, and vice versa. This R is not telling you that if it is positive, it means that more values of relative humidity explained. How will I say it now? That more, for example, now for the 15 days, some days, the moisture content, the relative humidity will have an impact on the moisture content some days. But this value is telling us that once it's positive, it means that more values of S explained the difference in the moisture content. Okay, for example now,
Increase in relative humidity.
example now, you have this father, this is son. He did this experiment for, let's say, five father and son. Let's say this father is 5 feet tall. The son is, let's say, 6. This one is, let's say, 6. This one is 7. This one is 4. The son is 3. This one is 5. This one is 5. This one is 6. This one is 6. Look at this table now. The first father is 5 feet tall. The son is 6 feet tall. The next one is 6 feet tall. The son is 7 feet tall. The next one is 4 feet tall. The son is 3 feet tall. The next one is 5, 5, 6, 6. You see that more, that if you have positive, it's telling you that more fathers that are tall, their son will most likely be tall. The large values of father will produce large values of son. But if it's negative, it means the reverse. Do you understand? Let's do an example, understand better. So this is this. So the work now is now to find R squared. Once you find R squared, you can find R. Once you're able to find R squared, you can find R. So our R squared, right here, R squared is equal to R squared is equal to 1 minus SSR over SY1. Then SSR is equal to XX XYY minus XXY squared all over XX.
Example 1.3.
So this value, this is this. So here now we have to find XX, XY, and YY.
Thank you, sir.
First, to find R squared, we need this equation. And this equation now is SSR over SYY. SSR is equal to SSS times SYY minus SXY all squared all over XX. So here now we don't know XSS, we don't know SYY, we don't know SXY. So we have to produce their formula. So XXX is equal to the summation of which you take the square of all your s and sum them minus total number of sample times the square of the s mean. For sy we have so that the formula they are looking alike, you can just find a way of memorizing it. They look alike. You don't have to memorize, so they look alike. So let's remember that the s is the independent variable and the y is the dependent variable. So between the father and the son, which one is dependent? Yes, independent. S is the
Son is dependent.
Yes, S is independent.
And
Y
Y
is
is
independent. You have to identify it first before you start. You have to identify which one is which. So it's like the son's age, height depends on that of the father.
yes,
So the son is now Y, dependent variable.
yes.
So it says the British statistician plotted the height of 10 randomly chosen sons versus that of their father. Determine how well the father's height explains the height of the sons and determine the correlation coefficient. That's page 9. Page 9. So our work is to find r squared. To find r squared. And our r squared is equal to 1 minus SSR
SR by S Y Y.
SSY. And our SSR is equal to this. We need to find SSS first. SSS is saying that we should square each S individually, then sum it up. Since here is now, this is Y, abi? Son is Y.
Yes.
Father is S. Then we should do 60 squared plus 2 squared till we finish. So this one is saying we should do 60 squared plus 62 squared till you get to the end, which is 74 squared. Minus n is their number, they are 10 in numbers. This is the square of the mean of S. This is S. The mean is sum everything, divide by 10. Then you now take the square. This S bar is mean. Mean of S is 60 plus 62 plus 54 till you finish. Which is to be 60 plus 62 gets 74 all over 10. Then you square your answer. Anything you get is now your SSX. Then for SYY. SYY is saying you should square the values of y individually. Y, that is some type.
Repeated the first one.
So it will be 63.6 squared plus 65.2 squared to get to the end, which is 70 squared, minus 10, which is the number, times the square of the mean of y. That be bracket 63.6 upon the 70 over 10. Then you now take the square. You now take the square.
Over 10.
No, yes, but that's the mean.
Yes.
No, this 10, you cannot cancel this 10. You cannot cancel.
I know it's not.
Because it has square outside, you cannot cancel. So the next one now is to find SXY. It's saying you should multiply corresponding values of S and Y and sum is all true. Multiply 60 times 63.6 plus 62 times 65.2 plus to exhaust to the end. So it means you can form a table for it to be easier. 60 times 63.6 plus 62 times 65.2. You need to get to the end, which is 70 times 74. So this is this first one.
It's 74 times 70.
This if you don't practice it, even myself, I've practiced my more than 2 times, but I still forget them. So you have to practice most as possible. Minus this end is the total number of 10
onto the mean.
The mean of S,
and
mean of Y. The mean of S is sum S through and divide by the number. That will give you the mean of S. The mean of Y also is sum Y throughout, divide by the number. You get the value of Y bar.
I think table is.
Table is more appropriate. So the table you have S, you have Y, you have S, Y, then you have
X here.
Which one?
We have S squared.
Do you have S? No. You have S squared. Yes. Do you have Y squared? We have Y squared.
I mean,
Then the mean is when you now sum SY. When you now sum this one,
Then divided by
by the time 10 will give you the mean.
can't we solve Y squared?
And you
To
can
give
sum
us the same answer.
Then
you sum this place now.
Yes,
Here now.
That Y squared in the table.
This
The
one.
Y squared, yes, if we sum it and divide it by the number
no,
of.
it will not give
So
us the
it
mean.
will
It will not give us the mean.
The mean is you sum the entire mean of S. Then this is mean of Y. So mean of S.
S
It's
squared.
different from meaning
Mean
of
of
Y
Y
squared.
squared.
You sum S
You add X together and then you
divided by the
10.
number. You get the mean. For Y, you sum Y together, divide by the number, you get the mean. So this one will give us S bar and Y bar. Here they were asked to find summation of S squared.